Hello, pre-calculus students. I am showing you pages 71 and 72 of your workbook just briefly because we have looked at this before in class, and by now we're heading into Unit 6.6 where we are going to put it all together, all 6 trig ratios for 30, 60, and 45-degree angles, as well as radian measures of those, so pi 6, pi thirds, pi fourths, and the quadrantal angles. So I bring this up to remind you that you can choose to learn the triangles like you see here on the left-hand side. And if you just use the triangles on the left-hand side, you can, using SOHCAHTOA, you can decide what the sine, the cosine, and the tangent are for 45 degrees, 60 degree, and 30-degree angles. It's as simple as saying, what is the sine of 60 degrees? Now, up here, you would have to say opposite root 3 over 2 over hypotenuse. And the triangle's not oriented like it is on the unit circle. But if you look over here, this is a second way to confirm. You know that another way to find these values is to just know the ordered pairs on the unit circle. So you would look here at 60 degrees, which is another name for pi thirds, and you would say, oh, the second value, the y value, is the sine value. So that's the sine of 60 degrees. You can either look at the triangle or you can look at the ordered pair on the unit circle. Then, if you get an angle measure that is not in the first quadrant, let's say the sine of 240 degrees. So let's say we're looking at the sine of 240 degrees. We can say, well, that's a multiple of 60. So if I know that the sine of 60 degrees, or pi thirds, is root 3 over 2, and I know that either by looking at the unit circle or using the opposite over the hypotenuse for a 60-degree angle. If I know that, then I should be able to figure out that the sine value for 240 is also root 3 over 2. However, it's over here in the third quadrant. So we know it's the same ordered pair, it's just that both sine and cosine are negative because the x and y values there are negative. So we're going to say sine of 240 is the same as the sine of 60, except we have to put a big negative right in the front. And then remember, the way we remember which trig ratios are negative or positive in a particular quadrant, we're going to remember the acronym all students take calculus, meaning all trig ratios and their reciprocals, so sine, cosine, and tangent, and their reciprocals will be positive in the first quadrant. In the second quadrant, only sine is positive and its reciprocal cosecant. In the third quadrant, only tangent is positive and its reciprocal cotangent. And in the fourth quadrant, cosine is the only ratio that is positive in the fourth quadrant, cosine along with its reciprocal secant. So in addition to the two ways we just talked about, either using the unit circle ordered pairs or just sketching out a triangle, we can fill out the rest of our trig study chart, which allows us yet a third way to determine the sine, the cosine, the tangent, and reciprocal values for any degree or radian measure angle. So take a moment, make sure that you have your radian measures filled in, and then we'll start up again. Okay, check your radian measures. Make sure you have all of your radian measures correct. Notice that all the 30-degree reference angles are in pi sixths, all the 45-degree reference angles are in pi fourths, and all the 60-degree reference angles are in pi thirds. 90-degree reference angles are in pi halves. Okay, now if you've got those all done, You should also have your entire first quadrant filled in for sine, cosine, tangent, and their reciprocal values. So take a moment, make sure that your your sine, cosine, and tangent values are all filled in for the first quadrant, 0 through 90 degrees. So check your first quadrant, make sure that you've got the values correct. Notice that for the first quadrant, sine goes from 0 and grows to 1. If you think about it in decimals, it's 0, 1/2 is 0.5, 1 over root 2 is about 0.7071, and root 3 over 2 is 0.866. So it's growing from 0 through those decimal values up to 1. At the same time, cosine, which is the adjacent side, that x value, starts all the way out at 1, but then it decreases to 0.866, 0.7071, 0.5, down to 0. Once we have sine and cosine, which you can get from the unit circle, or you can get just by drawing a 30, 60, 90 triangle and a 45, 45, 90 triangle, and finding the values that way. Once we do that, we can always get our tangent again by just dividing the sine by the cosine, or you can look at the triangle to see that the opposite over the adjacent for a pi sixth or 30-degree angle would just be 1 over root 3, which is also root 3 over 3. Once you've got that, you can just start doing the reciprocals. So the reciprocal of 1/2 cosecant is 2. The reciprocal of root 3 over 2 is 2 over root 3. The reciprocal of 1 over root 3 is just 3. That's why I left it in 1 over root 3 form, because doing the reciprocal is a lot easier that way. If you said root 3 over 3 and then flipped it and made it 3 over root 3, you would have to rationalize it, and you would still end up with the square root of 3 for the cotangent value. So there's the first quadrant, and now remember we just repeat that through the other quadrants. We repeat those values, and so for example, for sine with pi sixth, we say, okay, where are the pi sixth reference angles now? In the first quadrant, it's just pi sixth, but in the second quadrant, we're over here at 5 pi sixths, so that would have the same value. And then we remember all students take calculus. I'm in the second quadrant, so sine will stay positive. In the third quadrant, the sine value is still 1/2 for the pi sixth reference angle. However, we know now we're in the third quadrant, sine will be negative. Same thing in the fourth quadrant. The pi sixth reference angle for the fourth quadrant is 11 pi over 6, so it's 1/2 for sine, but it's negative. And then we can go through and do the same thing for the pi fourths. So sine of pi fourths is 1 over root 2, or root 2 over 2, so it will be the same for the pi fourths reference angle in the second quadrant, and it will be positive because it's sine. It will be root 2 over 2 in the third quadrant, but it will be negative. It will be root 2 over 2 for the pi fourths reference angle in the fourth quadrant, but it will be negative. Going back up to the pi thirds reference angle, we know it's root 3 over 2. So in the second quadrant, it will also be root 3 over 2. And stay positive in the second quadrant for sine. But in the third quadrant and the fourth quadrant, we've still got the sine value for pi thirds, but it will be negative in this third quadrant and the fourth quadrant. We can go through and do the same thing for cosine. But we remember the cosine values are negative in the second quadrant. So for cosine, a 30-degree or pi sixths reference angle will be here at 150. So it's going to be root 3 over 2. But for cosine, it will be negative. The 30-degree reference angle in this third quadrant for cosine, √3/2 again, but it's negative in the third quadrant. But then remember, all students take calculus, so that means cosine is positive √3/2 in the fourth quadrant. So using that logic, go ahead and take a moment and fill in the rest of cosine and tangent. Now check your work for sine, cosine, and tangent in the first and second quadrants. Notice the only positive values are the sine values. Cosine is negative, tangent is negative. Look at the third and fourth quadrants. Again, the only positive values are tangent values in the third quadrant. And then the only positive values in the fourth quadrant are cosine. Now, all we have to do is use the reciprocals. I know for tangent here, I used √3/3. We need to be very comfortable with the fact that that is also 1, oops, let me make that red, 1/√3. So that when we do the reciprocal, it's easy. We just do √3/1 for cotangent. And then for cosine, we say, now if cosine is negative in the third quadrant, then secant will also be negative in the third quadrant, so we can make it, and it's okay just to leave that. You also know that you could rationalize that denominator and get -2 √3/3 for that one. And then finally for your sine reciprocal, which is cosecant, it will be -2 because that's the reciprocal of -1/2. So walk through those and fill in your cotangent and your secant and your cosecant values, and let's see if we match up. Okay, so you should notice that all of the values that you have in the first quadrant now are just repeated in the second quadrant. I'll let you take a look at that real quick. They're repeated in the third quadrant. Let's go down. So that top set of numbers should look exactly like the bottom set of numbers as you read left to right. It's simply that we have positives and negatives now for particular ratios in different quadrants. The other thing some people struggle with a little bit is, when do I know, if something's undefined, like tangent of 3π². You know that that's undefined because it's the sine value divided by the cosine value. So you know that dividing by 0 isn't allowed. That's what makes tangent undefined. However, it helps us see why cotangent would be 0, because if I take the reciprocal of -1/0, it's 0/-1. So that's 0. So this table is just one more way. For some of you, you'll like this table version versus the other two options of just memorizing the unit circle ordered pairs, or drawing out your triangles and remembering ASTC. All students take calculus. Some of you will like this method the best because you will see patterns across all the different ratios. So whatever works for you, bottom line, you now this week will need to be comfortable, have a method for yourself to figure out, if we ask you what is the sine or the cosine or the tangent or any of the reciprocals of any of the values. So you are going to be responsible now in the coming week for having a quick, efficient way to answer what is the sine, the cosine, the tangent, or the cotangent, secant, or cosecant value for any of the angles on the unit circle, either in degrees or radians. You guys have learned a lot in the last couple of weeks. You have come a long, long way. So we hope that you finish strong here. You practice knowing these values, because this is what a big part of your midterm exam will be, is knowing how to evaluate different trig functions. So keep up the good work. Practice, 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 and you will be just fine. Thanks.